Alright, in the previous lesson we explored inner joins for the first time and we combined two data frames together, week 1 and week 2, based on common values in a single column, which was customer ID. In this lesson we'll expand on that process by looking at inner joins across multiple columns. So let's begin by re-executing our code and taking a look at the first two rows of our week data sets, so week 1 and week 2. In the last lesson we called the merge method on week 1 and we made it an inner merge or an inner join, and we gave an argument of a single string of customer ID to that on parameter. And what pandas did was look for common values, common customer IDs in both week 1 and week 2. And wherever it found a match, it basically merged those two rows together into one and gave us the final data frame. So all of the columns from the left and right were represented, and the values in the customer ID column were kind of merged together. Now, what that allowed us to see is those customers who came in on both week 1 and week 2. Now, what if we wanted something a little bit more complex? What if we wanted to pull in a new data frame of those customers who came in on multiple weeks on both week 1 and week 2, and also ordered the exact same food item on both week 1 and week 2? The process is basically going to be the exact same. I'm going to call the merge method on one of my data frames, in this case week 1, which represents the left data frame in Pandas syntax. I'm then going to open my parentheses, and the very first argument here is the second data frame that I want to merge, which is going to be week 2. That represents my right data frame. Again, just picture them on the same level, kind of side by side, and think of pandas as, pulling from each one and dragging towards the middle. Now the second parameter here is how, which represents the process of how it's going to merge them together. Again, inner is just one of many options. We'll explore some of the other ones in upcoming lessons, but inner only pulls in the rows where there are commonly shared values between both of our data sets. So I'm going to keep it for now. I'm going to keep the default argument, which is inner. And then after inner, we have that on parameter, which specifies on what column or columns we can merge on. And again, in this case, we're really lucky because both week 1 and week 2 have identically named columns. If they didn't, we'd have to do a slightly more complicated syntax. We'll dive into that again in a few lessons. But in this case, they both have customer ID, they both have food ID, just two columns, and both of them have the exact same titles, columns, casings, and so on. So now, instead of providing a single string argument, I'm going to provide a list. A list, as we know by now, is probably the most best and most common Python data type for providing more than one value at a time. So I'm going to feed in customer ID, comma, and then food ID in quotes. So basically what it's going to do is now it's going to look for matches across both customer ID and food ID. What this means is that both of those conditions have to be satisfied. If we have the same customer across 2 different weeks, but they didn't order the same food item, that is no good. Similarly, if we have the same food item ordered, which is certainly going to be common because we only have something like 10 food items but 1,000 customers, but if we have the same food item but different customers, then that's no good either. Only those occurrences where both the customer ID is and the food ID are exactly the same across both of these data frames, only those rows are going to be put together and merged for our final result here. So let's take a look. And here we're going to have a merged data frame. Now you may be wondering, where are all my multiple columns? Where is the suffix with _x and _y? Well, if you think about it, Pandas is actually being pretty smart here. In the previous lesson when we merged based on only a customer ID, so the values in the food ID column on the left and right could have been totally different. In this case, we're merging on both of those columns, so there's really no need to pull in the value from the right-hand column or really the left-hand column because they're both going to be the exact same. It's always going to be the same customer ID and the same food ID. So it's basically just going to pull in one value for both. There's no reason to duplicate it and add another food ID column, food ID from the left, food ID from the right. They're always going to be the exact same. So as we scroll down, we can see that this data frame is definitely shorter than the one in our previous lesson, and that's to be expected because the more columns that we add, the less we have chances of having duplicates or shared values among our two data frames. The more columns that we add, the less likely it is to run into the same values across all of them. And again, this is not either or. It's not customer ID or food ID. It has to be the same value in both. So there's only, in this case, 8 occurrences where this is so. Now we still see some duplicates in here. For example, on these rows we have a customer ID of 21 and a food ID of 4. Why is that occurring? Well, let's take a look at those customer IDs in our data frame separately. So I'm going to do week 1. I'm then going to do my extraction process by checking where the customer ID is equal to 21. And I'm going to do the exact same thing for week 2. This is going to replace my data frame reference. And here we can see why we have duplicates. As it turns out, we have a customer, they're identified with 21, came in twice on our very first week, and both times they ordered the exact same item. They ordered food ID item 4 twice. Then in the second week, they only showed up once, but when they did, they brought the exact same item. So now when it's running through all of these rows, it's saying, oh, customer ID, that's 21 exists in the other data frame. Oh, and that food ID also exists in the other data frame for customer 21. That means it's a match. I'm going to interjoin them. So it's going to drag this, basically drag this representation right here. And then when it comes into the second occurrence, it's going to say the exact same thing. This customer ID and food ID exist in the other one as a combo. So I'm once again going to identify it as a match and represent it here as well. So really this isn't so much a duplicate as it is just a separate row being created for every separate row that exists in our original data frame. And the same thing is true for 578. If I do 578 here instead of 21, we're actually going to see this in reverse. This is going to be a good example. You can see here that this is the opposite case. This means the customer came in once in week 1 and ordered the food item number 5. And then they came in twice in the second week and ordered the same food item twice, number 5. And once again, Pandas is going to identify a match between both the customer ID and the food ID across these 2 weeks. But because there's 2 matches, it's going to say, oh, there was actually 2 occurrences, 2 matches between the 2 purchases on the right side and the 1 purchase on the left side. It's basically crisscrossing and finding those that it can tie together, and however many crisscrosses it can make, however many connections or bridges it can build between those 2 data frames is the number of times that we're going to see those row values represented. So that's inner joins across multiple columns, no different than the process we've employed in the past. The only thing is now, instead of feeding a single string, we feed in a list of column strings, and that's going to identify the columns in which we want to look for commonly shared values. Both of them have to be met. If it's just one or the other, it's not going to work. And of course, in this example, we only did 2, but if you have larger data frames, you're more than welcome to expand it to searching for identical values in 3 or 4 or 5 columns, or however many you wish. Whenever those values from the right are going to be pulled in and merged with the values from the left. In this case, since there's really no point in duplicating the values from the right on the left, since we know that the customer ID and the food ID columns are both going to have the exact same values, that's precisely why they're being brought together. In this case, Pandas is smart enough to not generate those suffixes, those underscore X's and Y's, and just give us the data that represents those customers who came in on multiple weeks and ordered the exact same item each time. So that's inner joins, and in the next lesson we'll start diving into another way that we can merge, which is outer joins. So I'll see you there.